In this demo, we're going to use ePmotion 5075T to run an application for qPCR setup. In this qPCR setup, we have 6 standard with 3 unknown samples with 1 positive control. And we have 2 different master mix in this application. One is perf and PMT code 2 primer set. The other one contains human 18S primer set. On the table setup, we have a 4 skirted PCR plate on a thermal adapter, which is placed on the temp 2 position. And the reagent, we have a 24 position rack holding 1.5 ml tube. On position 1, we have water. Position 5, we have master mix for PMT code 2. And position 6, we have a master mix with a primer set of human 18S ribosomal RNA. On position 7, we should have a concentrated standard. From position 8 to 12, we're going to use this well for dilution, so they should have no solution inside. On position 13, 14, and 15, we have unknown samples, and at 16 position, we have a positive control. So let's start it. To run this program, we're going to select the detect volume and check the well or the liquid level in each well. We're going to select detect tips and check the lab well placement. Here we have 20 samples. That's because we have 6 standard with 4 control, and the other one is we have duplication for them. So here we're going to detect the liquid level. So we're going to select all used position. So the machine was started. And the first step, they're going to detect the lab well placement. The first is looking at the B2 position. This is a tip box. So they're going to detect what kind of tips on this tip box. And checking for how many tips is actually on the tip box. As you can see, you don't need to put an entire full box on this position. They can check which position is empty and which position have tips on it. And they will report how many tips is actually on this tip box and put in the running log. Right now it's checking on the B3 position. It's the same. This is 15 microliter filter tips. Checking for how many tips on the tip box. Right now it's checking the thermal adapter and checking the 4 skirted plate on the thermal adapter. The next, they're going to check the 24 position rack to hold 1.5 ml tube. And what it's doing now is checking the liquid level at the used position. This is at the 7th position, which we have a high concentrated standard. And position 8 to 12, we should have no solution inside the tube. On the position 13, 14, and 15, we have unknown sample. So the good thing is don't need to put how many volume you put actually inside a 1.5 mil tube, and you can ask EP Motion to detect by using their optical sensor. And the first step, we're going to transfer water from the first positions to dilution tube. In my application, I wrote to transfer 90 microliters in each dilution tube. And later on, I'm going to transfer 10 microliter from concentrated tube to the dilution tube and make it 1 to 10 dilution. Because we have using 50 microliter dispensing tools, so they have to dispense 45 microliter twice to make it 90 microliters in the tube. So the next step is going to do serial dilution. And what they will do is transfer 10 microliter from high concentrated tube to the dilution tube, which containing 90 microliter of water, and doing mixing for 6 times. I'm sorry, 10 times. You can change how many times for mixing. You can either select 3 times, 10 times, 20 times. And the mixing speed, you can also changing the speed from 7 millimeter per second to 30 millimeter per second. So right now it's about 22 millimeter per second. It's pretty fast because there's just water inside. If you are dealing with high protein containing solution or high viscous solution, you should reduce the mixing speed. Now transferring from the third tube, 10 microliters, to fourth tube, they contain 90 microliters of water, mixing. As you can see, during the mixing step, the tips is actually goes up and down, up and down. That's because the tip is moving with the level of the liquid. So right now it's going to do the last dilution. After serial dilution, they will dispense the master mix from position 5 and 6 to the PCR plate. In your setup, you're going to put the standard on B2 to B5, and all the standards from position B to position G. Today we're going to do duplication. So we're going to dispense the first solution to B from B2 to G2 and B3 to G3. It's 50 microliter each dispensing. So I choose pipetting mode. This will be more accurate. However, as you can see, it takes more time. On the second master mix, I choose multi-dispensing. Then you will see it's faster, but the accuracy might sacrifice a little. So still in pipetting mode on G1 and G2 and G3. Okay, so right now is pipetting the samples for unknowns. Sorry, pipetting the master mix for unknown samples at position B5, B4, B5 and B6. To E5 and E6. So we finished the first master mix transfer. On the second master mix transfer, I switched to multi-dispensing mode to let you know how it works on the multi-dispensing mode. Okay, so they finished the master mix transferring. So now they're going to transfer the sample to the PCR player. From here, they started with standard and transfer replication on B2 and B3 position, which is 5 microliter each. And after transferring, they're doing mixing for 3 mixing steps. And because of this, it's a mixing step, so we're going to change the tips every time we do transfer. Of course, you can increase the mixing, the times of mixing step. So right now it's 3. You can increase to 7, 10. However, you will increase the time on EP motion. The other way is you can also just dispensing and using vortex to mix the solution after you dispense. This is the duplication on second standard. So right now it's working on the third standard on D2 and D3 position. As you might notice, we still have plenty of room for samples to load it. So this application can hold up to 16 samples and do triplication on the 96 well plate. And we still have plenty of room for tips. From this application, we can enlarge to using 8 standard plus 24 samples on one plate. Right now it's transferred the last standard to G1, G2, I'm sorry, G2 and G3 position. Mixing. So for this application, I just use water instead of real master mix. So if in the reality, if you're going to use master mix, because that's a little bit viscous solution, so we might need to adjust a little bit on the liquid method. So right now it's transferring unknown sample, the first one. In the future, if you have a lot of samples to run, you can try to dispense your sample into 96 well plate and put your samples on C4 position and use 8-channel tools to transfer your samples to the PCR plate. And you will much faster than using single channel tools. So right now is the third unknown sample. transfer 5 microliter and mixing. And the last one is your standard with the first mass mix recipe containing perf and PMT code 2 primer set. And now they're going to transfer the samples, unknown samples and standard to the second master mix recipe well, which is at B8 and D9 positions to E8 and E9. So as you may notice, this is a thermal module, and we actually put 4-degree temperature control on the thermal module. So the entire plate is keeping at 4-degree, and that can prevent any reaction happening in the PCR plate. We also have a TMX module here in the back. If you want, we can put this reagent rack on the TMX and keep it at 4-degree to prevent, if you want to control your master mix at 4-degree at all times. So right now it's transferring the third unknown samples on D9 position, mixing. And the last is going to transfer the positive control on E8 and E9 position. After application done, we can introduce a user intervention step to put a comment and remind you how many PCR program you need to, how many cycle and the temperature for your PCR program has to be set up. So that's it. The entire application is finished, and if you want to just put the dispensing tool back to the tool holder. and the entire application is finished. So what you can do now is open the sash and seal the plate with the film and run it on the thermocycler. That's it. Thank you very much for watching.